So let's start with it. So data objects and attribute types we have seen, basic statistical description of data we have seen. So now we have to see this one, data visualization. So these are only the graphs or visualization tools which are used to plot the data or plot the information in some kind of a pattern. Okay. So let's see this data visualization. See here. Okay. Data visualization. Why data visualization? Because how can we convey data to users effectively? So data visualization aims to communicate data clearly and effectively through graphical representation. Data visualization has been used extensively in many applications. For example, reporting, managing business operations, and tracking the progress of data. More popularly, we can take advantage of visualization techniques to discover data relationships that are otherwise not easily observable by looking at the raw data. Nowadays, people also use data visualization to create interesting graphics. Okay, so in this section, what we are going to see is we briefly are here just if there is an introduction of basic concepts of data visualization, and then we start with the multidimensional data such as those stored in a relational database. We will discuss several representative approaches including pixel-oriented techniques, geometric projection techniques, icon-based techniques, and hierarchical and graph-based techniques. Okay. We also then discuss the visualization of complex data and the relations, right? So, why data visualization? To gain insight into an information space by mapping data onto graphical primitives. To provide qualitative overview of large data sets. To search for patterns, trends, structure, irregularities, relationships among the data, to help find interesting regions and suitable parameters for further quantitative analysis, and to provide a visual proof of computer representations which are derived. So what are the categorization of visualization methods? First one is a pixel oriented visualization technique, then geometric projection visualization technique, then icon based visualization techniques, then hierarchical visualization techniques, and visualizing complex data and relations. So first of all, pixel oriented visualization techniques. So it is a simple way to visualize the value of dimension. It is used. It uses a pixel where a color of the pixel reflects the dimension value. Color of the pixel represents the dimension value. So for a data set of m dimensions, pixel oriented techniques create m windows, okay, on the screen, one for each dimension. The m dimension values of a record are mapped to m pixels according to the position in the window. Okay, so this is a for a data set of m dimensions, create m windows on the screen, one for each dimension. The m dimension values of a record are mapped to m pixels at the corresponding position in the window. The colors of the pixel represents the corresponding value. So, for example, this is a uh, pixel oriented graph of income. This is a graph of credit limit. This is a graph of transaction volume, and this is a graph of age. Okay. So, for example, here, suppose take the example of a all electronic shop which maintains a customer information table which consists of 4 dimensions. So these are the 4 dimensions. What is this? First one is the income, then credit limit, then transaction volume, and then age. So can we analyze the correlation between income and other attributes by visualization? Income and other attributes. Okay. So we can sort all customers in income ascending order and use this order to lay out the customer data in the 4 visualization windows as shown in this diagram. The pixel colors are chosen so that the smaller the value, the lighter the shade. So using pixel based visualization, we can easily observe what things we can observe here. Credit limit increases as income increases here. Credit limit increases as income increases. Customers whose income is in the middle range are more likely to purchase from all electronics. Here, transaction volume. Okay, and there is no clear correlation between income and age. So there is no correlation between income and age. So in these pixel oriented techniques, data records can be ordered in a very dependent way. For example, given a point query, we can sort all records in ascending order of similarity to the point query. Okay. So filling a window by laying out the data records in a linear way may not work well for the wide window. Okay, so this is what is the, it shows the relation between the 4 criteria, that is what is the impact of income on credit limit, transaction volume and age. So this is example of pixel oriented visualization technique. Okay, so laying out pixel in circle segments. So what is this is to save space and show the connections among multiple dimensions. Space filling is often done in a circle segment. So this is first diagram. It representing a data record in a circle segment. How many dimensions are considered over here? 1, 2, 3, 4, 5, 6. Now what are dimension? Dimension is this. Here, this income, credit limit, that means columns. What we can say as columns of a database. So these are dimensions. So this is a one record. So suppose we take a one data record, we can plot all dimensions. That is the first dimension, suppose income, second dimension, suppose credit limit, third dimension, suppose age. So all these points have been drawn over here for single one record. Okay, so it represents a data record in a circle segment, right? Now laying out pixel in a circle segment. So this is a pixel. Okay. So again this is plotted one dimension, second dimension. So this is called laying out pixels in circle segments. So this is a circle segment. Each record has been placed over here in a circular position for all dimensions. So this saves the space. Okay. So this is called laying out in circle segments. Now next one is a geometric projection visualization technique. So geometric projection. So what is the drawback of pixel oriented visualization technique is that they cannot help us much in understanding the distribution of data in a multi-dimensional space. For example, they cannot show whether there is a dense area in a multidimensional subspace or not. So, geometric projection techniques help us to find interesting projections of multidimensional data sets. Okay, so visualization of geometric transformations and projections of the data. What are the methods? Direct visualization, scatter plot and scatter plot matrices, landscapes, projection pursuit technique help users find meaningful projections of multidimensional data, projection views, hyperslice and parallel coordinates. So these are all the methods of geometric projection visualization technique. Okay. So this is direct data visualization, this one. So we are going to see all these methods one by one. So this is a direct data visualization. So this is a ribbons with twist based on, see, observe this diagram, these are ribbons. Okay, so this is just data which is plotted in this format. So this is direct data visualization. These are the ribbons which are plotted over there. Then this one is a scatter plot matrices. We have seen scatter plot positively correlated, negatively correlated, or neutral. So these are all neutrals. This is positively correlated. This is uncorrelated. This is also positively correlated. Okay. So these are all scatter plots. So matrix of scatter plots, X-Y diagrams of the k dimension data. Now these are the landscape. So this is a landscape. So see the graph. This is a visualization of the data as perspective landscape. The data needs to be transformed into a possibly artificial 2D spatial representation which preserves the characteristics of the data. So what is this? News articles visualized as a landscapes. So, so these are all news articles. What are articles? Police, dogs, soldiers, then court, person, children, FBI, rescue. So these are all news articles. So see here, landscape, court and FBI have been, see, you can see this. So more of the news are from court and FBI sector. So this you can say, see the landscape view of the data. So what data it is? News articles visualized as a landscape. Now parallel coordinates and equidistant axes which are parallel to one of the screen axes and correspond to the attributes. The axes are scaled to the minimum and maximum range of the corresponding attribute. Every data items correspond to a polygonal line which intersects each of the axes at a point which corresponds to the value for the attribute. So these are parallel coordinates. So this is attribute 1, attribute 2, attribute 3, attribute k. So this is how it is plotted. Now parallel coordinates of a data set. So if we see it through a other visualization technique or tool, so this we can see over here like this. Okay. So these are all just visualization tools. We are just looking through it. We just have to know the names and how it looks like. Okay. Now icon based visualization techniques. Visualization of the data values as features of icons. So what are the typical visualization which are based on icon based visualization is the Chernoff faces and stick figures. You might be knowing it. So what is the general technique? Shape coding. Use shape to represent certain information encoding. Color icons. Use color icons to encode more information. And tile bars. Use small icons to represent the relevant feature vectors in document retrieval. Okay. So these are Chernoff faces. A way to display variables on a two-dimensional surface. For example, let x be eyebrow slant, y be the eye size, z be the nose length, etc. Okay, so these are all dimensions. Eyebrow is one dimension, eye is another dimension, like this. Okay, so two-dimensional. The figure shows faces produced using 10 characteristics. Head is eccentricity, eye size, eye spacing, eye eccentricity, pupil size, eyebrow slant, nose size, mouth shape, mouth size, and mouth opening. Each assigned one of the 10 possible values generated using Mathematica. Okay, so these are the Chernoff faces. Now stick figures. These are all stick figures. This is a age and income. So this is a graph of age versus income. So a census data figure showing age, income, gender, education, etc. A 5-piece stick figure, one body and 4 limbs. One body, for example, consider this. This is a one body and 4 limbs. 1, 2, 3 and 4. So these are the 4 limbs with different angle and length. So these are called stick figures. Okay. Then hierarchical visualization techniques. Visualization of the data using a hierarchical partitioning into subspaces. So what are methods for that? Methods are dimensional stacking, worlds within worlds, tree map, cone trees, and info cube. So these are all variety. We can draw a plot. Okay, dimensional stacking. So this is a dimensional. Normally, your data warehouse uses this. This is the attribute 1, this is the attributes 2, and these are attributes and dimensions. So this is attribute 3, attribute 4. It's a multi-dimensional cube. So partitioning of the n-dimensional attribute space in two-dimensional subspaces which are stacked into each other. Partitioning of the attribute value ranges into classes. The important attribute should be used on the outer levels. Important attribute should be used in the outer levels. Adequate for data with ordinal attributes of low cardinality but difficult to display more than 9 dimensions. So if the dimensions are more than 9, then it becomes difficult. Important to map dimensions appropriately. So when we will be studying data warehousing, we will be using this cube. Okay. Now dimensional stacking, visualization of oil mining data with longitude and latitude mapped to the outer XY axis and ore grade and depth mapped to the inner XY axis. So this is outer XY axis and inner XY axis. These are outer, these are inner. This is worlds within worlds. Assign the function and two most important parameters to innermost world. Fix all other parameters at constant values. Draw other 1 or 2 or 3 dimensional worlds, choosing these as the axis. So software that uses this paradigms is Envision. Dynamic interaction through data globe and stereo displays including rotation, scaling and translation. Autovisual static interaction by means of queries. So as you can see how the graph is plotted. Okay, so this is called world within worlds. Now next one is a tree map, right? Screen filling method, which uses a hierarchical partitioning of the screen into regions depending upon the attribute values. So this is a screen, suppose, and it's a partitioning of the screen. So suppose this is a screen, it is partitioned again. This is a screen, it is partitioned again. This is a screen, it is partitioned again. The x and y dimension of the screen are partitioned alternately according to the attribute values. So what is this image is MSR net scan image. Then tree map of a file system. This is a tree map of the file system or file system. How files are allotted or located in the memory. This is a info cube, a 3D visualization technique where hierarchical information is displayed as nested semi-transparent cubes. The outermost cubes correspond to the top level of data, while the subnodes or the lower level data are represented as smaller cubes inside the outermost cubes and so on. So these are the outermost cubes and then the levels of the cubes. So this is an info cube. Then 3D cone trees. These are the 3D cone trees. 3D cone tree visualization technique works well for up to the thousands nodes. So first build a 2D circle tree. It is not actually visible. Okay. Right. 3D cone tree visualization technique works well for up to the 1000 nodes or so. First build a 2D circle tree that arranges its nodes in concentric circles centered on a root node. Cannot avoid overlaps when projected to 2D. So this is just a visualization technique. Then visualizing complex data and here relations. So visualizing complex data and relations. Visualizing non-numerical data, that is text and social networks. Tag cloud, visualizing user-generated tags. The importance of tag is represented by font size and color. The importance of tag is represented with the help of a font size and color. Besides text data, there are also methods to visualize relationships such as visualizing social networks. So this is a news map, Google News Stories in 2005. So this is a map of Google News Stories in 2005. Okay, so here we end with the data visualization. So we have seen data objects and attribute types. We have seen the basic statistical descriptions of data, and today we are done with data visualization. Tomorrow we will be starting measuring data similarity and dissimilarity. Okay, so let's stop over here.